Okay, this one is question 9. Let's have a read of it. It says A is the midpoint of PC, so that's just there, and B is the midpoint of PD, and B is just here. AD and BC intersect at X, which is just there, and we're asked to prove that the ratio AX to AD is 1 to 3. So AX to AD is 1 to 3. Okay, so let's just write that down. And I'm just going to write a statement. If the ratio AX, so AX to AD is equal to 1 to 3, we can write from here 1 to 3. From here, I can write therefore on here, we can say that AX, so AX is going to be equal to 1/2 now of X to D. So that's my first statement. And I'm just going to rule that off there. So that's the first statement I'm going to make. Okay, what we can use here is the midpoint theorem. So I'm just going to jot down midpoint. So we can say now midpoint theorem. So midpoint theorem, just jotting this down. We can say now that if A is the midpoint of PC and B is the midpoint of PD, and you might want to write that out. So if A mid P, just write this a bit cleaner, and we can say B is a mid of P to D. We can say from this that AB is parallel to CD and 1/2 the length, so half the length. So half the length, and that's the midpoint theorem. So anything along those lines, you might want to put that a bit nice in this way. So that's what I'm going to do. Now let's think what I can do. Similar triangles. We can use similar triangles. So using similar triangles, I don't know how thorough you want these to be. So similar triangles, we can say now from here that this triangle right here, and let's try and let's just get a different color up. Right, that triangle from here to here to here is similar now. So we've got AXB is going to be similar to, and let's put on a different one. So that is going to be similar to that one. Okay, so let's just put this on. We can say now similar triangles, triangle, and if you want to do that notation, you can do it. We can say triangle AXB is similar now, so similar to triangle, and what have we got? CXD. So CXD, and we can say it's going to be on here. Now, if it's similar, 1/2 the size, given now this midpoint theorem, because AB is half the length, okay, and half the size, half the size. Okay, so let's just put that on. So similar triangles, it's similar as we can say, and if you want to put in brackets now, AB is equal to 1/2 CD. So from that, so from what we can do on this now is simply, and if you want to get a visual representation of what I'm going to do here, I'm just going to draw it up here. Let's just draw that up and put that just there. This at the top is going to be X, so we can put X just here. Oh, let's just grab that out. Might be a quicker way of doing this. I can't see it yet, but I'm happy to listen. Right, that's X, that's B, so let's, and that's A when the computer gets itself into gear. Come on, hurry up. Right, let's just put that there. So that is B. This right here is A. This one is going to be C. This is going to be D. This now, if we say what we've got here now is we'll say that now that is split up like so. These two lengths are the same as this is half. And what we can say now is if we have this one right here, and I'll use 3 of these and 3 of these, we can show from this similar triangle. So similar triangles, it's half the size. Therefore, we can say now A to X is going to be equal to 1/2 X to D from this. And that goes back to what I've put here. Similar triangles, if we know that this length, so let's just say that this length was 5, then this one is 10 from what we proved on the midpoint. And we can see that this splits it, and you might want to say that splits it again, a midpoint, because I don't know how accurate. So if you want to put, if AB is parallel to CD here and half size, so half size, we can say that A is the midpoint, so the midpoint of XD. That would probably be my way, something along those lines. I can't see it being any quicker than that. More than happy to listen if it is, but it's using the midpoint and similar triangles. So that's that one. See what you think to it. As I say, I'm open to listen if there's a quicker way, but something first using the midpoint and then using similar triangles, and then simply showing that A to X is 1/2 of X to D.